All right, guys. Again, doing things a little bit different here. We are skipping student activity sheet 2. I am jumping to student activity sheet 3, exploring rate of change. We're on page 8 of 13, question 25. Okay, so we're making some changes. So if you need to turn to that page, let's go ahead and get there. So the big thing we want you guys to take out of this is a couple of key words here. Okay, so the first thing here, what you can see on the screen, we are comparing the number of ice cream cones sold and the number of reported shark attacks. Okay, on our other activity sheet, we talked about correlation with its positive correlation, negative correlation, and our data points being tightly formed together. If I look at this, guys, I see that there is a positive correlation here, right? I mean, it seems pretty obvious. The more ice cream cones that are sold, the number of reported shark attacks goes up. One would even be so inclined to say that the number of ice cream cones causes the shark attacks. No, that's not the case. Okay. Correlation is not causation. Okay. What I need you guys to understand, we talked about the word correlation before. Okay. Yes, there is a strong correlation amongst the data points here. Correlation means tightly knitted together. Okay. The points are tightly woven around a line of the positive form. Okay. Causation. Okay. Causation. I want you guys to think of cause and effect. Okay. The number of ice cream cones sold does not cause the number of shark attacks. Okay. Think about that, guys. It doesn't make sense. Do you really think eating ice cream causes more shark attacks? No. But what that typically means, guys, is that there is a relation of some sort. Okay. There is a relationship of some sort. With this, let's talk about it. Based on our scatter plot, could we make a reasonable prediction of the number of shark attacks if we knew the number of ice cream cones sold? Yeah, we could. We could make that prediction, guys. I could say, oh, hey, 1,500 ice cream cones sold. Well, look at that right about here. And we'd say there'd be roughly a little bit over 20, 25 shark attacks. I mean, we could make that prediction. Okay. But does that mean that eating ice cream causes shark attacks? No, guys, no. While it seems that way, okay, it's really the fact that when do we eat ice cream? When it's hot out. When do we go swimming in the ocean? When it's hot out. We swim that time of year. The more people swimming in the water means that there's a greater chance of a shark attack. So while those two things are correlated, they have a relationship. One does not cause the other. Okay. One does not cause the other. So let's look at a couple of other examples here. Okay. Another example I have here, guys, number 26. We've got the curb weight in pounds of a vehicle. Guys, this is like the car weight. Okay. And then how many gas, the amount of gas consumption in miles per gallon. So how much gas the car uses. Okay. So when I look at this, guys, the first thing I notice about this graph is that there is a negative correlation. We could say that the trend line is about right there, right? There's the trend line. It is tightly correlated to a negative line. With that said, I can assume that the more a car weighs, the less miles per gallon that the car gets in terms of gas. But And that's what we call fuel economy. Again, as the weight of the car increases, the fuel economy decreases, our miles per gallon. If you want to put that, miles per gallon. Okay. They want to know, is there a causal relationship? Okay. We see that there's a correlation, but is there causation? No, guys, no. It is not necessarily. We don't know why that is. Typically, what happens, guys, is that if you think of my own vehicle, I drive a big old Lincoln Navigator SUV. It's kind of like a Suburban, okay? And then you think of Mr. Case's Toyota Corolla. Mr. Case, I'm sorry if that's not what you drive. I just picked a small car, okay? If you think of my car compared to his car, who's got the bigger car? I do. Okay, I have a big old giant engine in my car where I feel like I can say, get out of my way. Okay, well, the downside, guys, is that my engine weighs a lot more. Okay, which means that it's heavier. It has a less efficient engine, which means it's going to burn through more gas. Heavier vehicles have less efficient engines. Now, things have also changed, guys, where my husband's pickup truck gets better gas than my car. And his car I think I would say it's heavier. I don't know. Okay. So there's a lot of factors there, but typically heavier cars have less fuel efficient engines. It's not that they get less miles because they're heavier. It's caused by something else. Okay. And then lastly, let's compare a couple other things here. We have two things. The first is, let's go back to that original problem of our height compared to our shoe size. And then we're also going to talk about the number of marbles in a cup. I may have to draw a picture. We've got like a table here. And what they did was they hung rubber bands and they put a cup here. And they put marbles in the cup. Boop, 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 boop. And they saw like how many marbles it took to make that hang further and further down. So with this, they want us to know in each of these cases, a couple of things. They want to know, is there a causal relationship in either of these situations? Okay. Let's come over here to height and shoe size. We can see that the taller you are, the bigger your shoe size is typically. But is this caused by one thing? No, we cannot say that, guys. We cannot say that our shoe size is directly related to our height. Okay, there's other things involved. I have bigger feet than my mom, but my mom is taller than me. Okay, there's nothing set in stone. Okay, there's other things that to take into consideration with that. But if we look at the number of marbles, guys, every time I drop a marble in, that cup is going to get further down. Nothing else matters there. And if you notice, these data points are not randomly scattered. They are going in an increasingly steady line. Okay. So yes, we can say that there is a causal relationship between the marbles added to the cup, because the number of marbles added causes the distance to increase. There are no other variables to consider in this problem. Drop the marble in, the cup gets closer to the ground. And that would be it for this activity sheet. Have a good day. Bye.